Uh, Summer 2019, paper 1 to paper 1, variant 2, 9702 age level, question number 21, and this topic is related to the density. Before doing this, I suggest you should understand this. In order to analyze density at microscopic level, we can consider the atom as a cube or or as an sphere. So both can be considered, right? Either you consider that the structure of an atom is like a cube or an sphere. So by doing this, and let's check the question. The question says the diagram shows the arrangement of atom in a particular crystal. Each atom is the corner of a cube. The mass of each atom is 3.5 into 10 power minus 25 kilogram. The density of the crystal is 9.2 into 10 power 3 kilogram per meter cube. So you see the mass is for the single atom and the density is for the crystal, which is 9.2 into 10 power 3 kilogram per meter cube. What is the shortest distance between the centers of the two adjacent atoms? What is the shortest distance? So we need to check this. What is the shortest distance between the centers of the two adjacent atoms? So first of all, if we consider this, we can analyze a density of at microscopic level. We can consider the structure of an atom is like a cube or a sphere. So if we consider this, and if we consider this, what is the shortest distance between the centers of the two adjacent atoms? If we consider the shortest distance is only when the cube is very close to each other. So the center to center is the length, which is approximate, which is actually equal to this. So this is the length, and this is also the size of the cube. So if we find the length of the cube, we can find the distance between center to center of the cube. Got it? So first we can analyze, we can consider a density at microscopic level. We can assume the atom as a cube or atom as a sphere. And if we consider the atom as a cube, so this x is the length between the center to center, which is the shortest distance. This is the question which is asked. Okay. So the next point we should consider for the closest atom in Q when such arrangement is there. So the density will remain the same on both molecular level and microscopic level. Whatever be the density at the as a crystal, the density it has. Now, if the arrangement is closest, that means the density of the crystal is same as the density of the atom. So, by considering this fact, we can straight away use the information like density equals mass upon volume. So, density will be the atom is considered as 9.2 into 10 power 3 kilogram meter cube because the density of the crystal is same as the density of the cube. Why? Because the atoms are very close to each other, right? So there is no space between them. So whatever be the density of a crystal will have the density of the cube. So we will use this density value. And we know what the mass of each atom. So the density equals mass over volume. The volume equals mass over density. So we will get 3.5 into 10 power minus 25 over 9.2 into 10 power 3. We will get 0.38 into 10 power minus 28 meter cube. So if we consider the atom as a cube, so the length of the cube is what's what? The cube root of this volume because it's a cube. So L will be 3.36 into 10 power minus 10 meter. So this X is actually the L, the length of the shortest, the L is the X is the shortest distance between the center of the adjacent atom. So X will be round of 3.4 into 10's power minus 10 meter, which is option number C.